Welcome, everybody. Tonight is the 6th of December, and we are having our regular Robot Builders Night Out online, virtual, whatever you want to call it. We'll skip that part. Just again, as a kind of a housekeeping. The only things on the calendar at the moment really are up here in the top right part. Kareem is looking for volunteers for the 10th of December competition. So we have a couple, I think, online who've already volunteered. And if you're open to that, it would be wonderful. He could appreciate the help, and the kids appreciate it. And it's a pretty fun time. I've done it once or twice, but I can't this year. I'm out of town. And then on the weekend after that, we have a penciled in tentative for the Iron Rain team to present at a monthly meeting. So they'll give a progress update and a practice presentation. Aside from that, I don't really have any updates. Does anyone else have anything to throw in the mix at this point on that? Okay, hearing nothing. So then, great. So if we want to get started, we'll just go around the table like we normally do. The queue we have so far is Scott, then myself, then John G, then John K, then open table free-for-all. So with that, Scott, would you like to get us started?
Sure. Yeah, I was just going to give an update on Belch. I finally figured out what was going on with my software, and I thought it'd be a good lesson for anybody that writes in C. There was some discussion at the contest, and John, you and I were talking about different ways, and one of the suggestions that was made was, you can test each module independently, which I'd kind of done because I'd dragged this software around different projects. But what I was able to find is I was using an intrinsic C library, a function called string toke. Right, and basically, for those not familiar with C, it's a way to break up strings in C, and it's an intrinsic library function. But it turns out it's not thread safe. So if you use it within a thread, and in my case, I use it both in my GPS thread and also my AHARS thread, because the GPS spits out NEMA messages, which are just text-based messages, and you have to break them up based on the commas. And my AHARS is a very similar kind of thing, where it's a string that's delimited by commas. So what was going on was, if these two threads were calling string toke, then the pointer that was returned from string toke basically becomes null. So even after you've tested the string that you're looking at and said, yeah, it's a good length, and it's minimum length, and it has these tokens in it, or these tags in it, so I'm going to go ahead and start parsing it up. Well, after you've done those tests and you start parsing it up, the way string toke works is you recall it repetitively, looking for each individual token. And when it returns a pointer to that token. Well, if another thread has called string toke in between those calls, then you get back a null pointer. So when you go to convert it into a number or something else, things blow up. And so that's what I was able to find was making the software crash on Belch. Took me a while to track that down, but I thought it'd be good just to bring that out, because I've written C code for years and never realized that was not a thread safe function. Maybe my own naivety, but so that's kind of the lesson that I learned. I was hoping Doug was going to be on here, because I'm working. Oh, there he is.
He's just arrived.
I'm working on getting my Oak D Lite, or actually I think it is the Oak D Lite, tied into my Raspberry Pi. How did you interface with yours, Doug? Are you using the Python libraries, or?
Okay, got my model up on RoboFlow. Okay.
Yeah, but when you're using the data,
well, and then I have a Python script that basically the model is stored in the OAK-D Lite. Okay, because of it's kind of magic behind the scenes, because you don't, once it's in there, you don't need Wi-Fi or anything. And sometimes you can, I think it even stores more than one, but you have, so once you have it up in your OAK-D Lite, you just call it and like you said,
yeah.
parse it
I
out.
mean, I've run their examples and whatnot, both in the Python's examples and their C examples. And I really struggled getting their library to compile and to link into my program. But I was finally able to do that. But their API, the documentation on their API is really kind of thin.
Yeah.
So I'm having trouble with some of their APIs, and I don't have a lot of, information to look at to say.
Is this talking about the OAK-D Lite?
Do what?
You're talking about the OAK-D Lite, right?
Yeah.
Okay, so you have to, the way I see it, I think since it's got a Movidius chip in it, they're somehow turning it into an open VNU model. Okay, so that's, I think, why it's persistent. And so there's a script, if you're using RoboFlow, that's available that makes getting the data very easy. I can put a link into it here in a minute. I'll go look for it. Okay, and it's just one of those things. It's very easy. The hard part is getting the model. You know what I mean? The hard part is getting the model. And you got to remember, that's the only thing I'm really doing on the Pi. So the Pi, even though it's Python and everything, it really has no trouble, returning the results. So, like I say, that you're welcome to use my model. It's up there on there. If you go up to RoboFlow and just, I think it's called Robo Columbus. And
yeah, I haven't got quite to that point yet. I'm still trying to get like I said, the C library linked in and get the functions working correctly.
Okay, you're doing it. You're trying to do it. Otherwise, what I'm doing is pretty cut and paste, because, like I say, I'm just using the let RoboFlow train the model. Then I'm just using the results of that trained model to feed my in my case Teensy. So it's just a serial port output. I can show you the script, or we can do that. We can look at that or whatever.
Yeah, well, the way you're doing it, though, that's a whole different.
Yes, it's very, very, very easy to do it the way I'm doing it. You're trying to understand how it works, and I understand that. But I'm going, since it gives me access to the distance information and the model information, that's all I wanted out of the OAK-D Lite. I didn't want anything else out of the OAK-D Lite. I'm not trying to special purpose the OAK-D Lite. I'm just using, all I want is, I want to know what objects it sees. And so right now, I'm kind of looking into how do I use regions of interest, and getting that so my what I'm trying to do is, if you know where it says a cone is, the centroid and the size of the bounding box, and just take that and make that a region of interest, and look for the average distance in that region of interest. That's what I'm planning on doing. So there's a couple fallacies. For example, I see it that there's if you look at it, there's really a couple of zones if you're depending on the OD light. Okay, you're in the early stage, you don't see the cone, so that's pretty straightforward. That's like we always do. Then once you start seeing the cone, it's really pretty robust. But when you get closer and closer to the cone, and the cone gets more and more of the field of view, it gets a little iffy if it sees it every time. Do you know what I'm saying? It'll call it a cone some of the time, but it might not call it a cone all the time. So when you get to that point, you really need to say, "Hey, look, last time I looked at it, it's right straight in front of me. It says it's X distance. Go for it," because it can probably you can probably get distance up to about 15, 20 feet. So that makes it really kind of nice. And you can see the cone probably at about 30, maybe 35, but 30 feet. So, or at least with what I saw with my model. So you have some, as you approach it, I guess if you zoom in by, it'll be a problem maybe. But if you're traveling the speed of most of our robots, it shouldn't be an issue. So I'm just saying I don't know if that helps, but I can get you the link that I used as a starting point, and I can show you the code that I'm doing if it is of interest. Yeah.
Yeah. Well, if it's in Python, then not really. I mean,
Okay, I got you. Well, that's I understand. Yeah. You can probably in actuality, you could probably, the only thing that might be tricky is calling the results. They're in, you know how Python uses all sorts of different arrays to store information.
Yeah.
And in one of the data comes to you in one of those special formatted arrays, but I would imagine that there are C functions that do similar parsing of that. And in that case, you could probably write the rest of it simple stuff. The one key is getting the data array from the model. That's the key part. And since they showed an easy way of doing it, I took it. But there may be maybe if you look at their Python script, you might be able to figure out how to do it completely in C.
Well, I mean, they have C examples that mirror the Python examples.
Okay, all right.
I mean, I
haven't seen that for RoboFlow. That's why I'm just. But
yeah, I mean, I know the functions you're talking about, and they have similar functions in the C library to do the same thing. Mm-hmm. Like the objects, you can query the objects on the screen by name, and then start pulling properties from them. Like you were saying, it's an array of objects that it returns.
Yeah.
And you scan through the array looking for whatever name that you've given it, from the blob.
Right.
So it's very, very much the same from Python. But now I have the C++ compiler in my way and the linker in my way, and but I have so much other code, and the core of it all runs within the C functions that I already have. So I'm still just trying to get this plugged in.
So that's what I'm saying. It might be easy to just plug it in and use the Python code that I can show you it works. And you can get it, and then you can say, "Oh, okay. Well, now I know." You might have a better picture. Now that's if you're going to use RoboFlow to do your modeling. If you want to use TensorFlow or something, but that's probably going to be more Python than you want. So something to think about.
I wouldn't, since I can query the objects, training it is one thing, but just pulling the data from the image is a whole, different step.
Well, the training is, to me, getting the data set and training. And there's one of the things, how I have it set up there's only one classification, and that's traffic cone. Okay. And so it either sees one or it doesn't see one. And the other thing that it does is in the data set, there's even null images. So to help strengthen that particular function. So like I say, you're welcome to go use that trained model, and it would save you a lot of time, I think, if you just want to.
Yeah. Well, I think you said it was on RoboFlow, I think.
Yeah, it's on RoboFlow. I think the actual model is named something like TC, but I think if you were to look for it, I think you look for the project called Robo Columbus. There's also, Jesse Beckman, his project, or he apparently messed with it a little bit, and his project is up there too. But
yeah,
a lot of his is private. He must pay money or something to do that.
Okay.
Okay.
That's all I had, Carl.
Okay, cool. Well, glad to hear that is it STR Talk? Is that the one?
It's STRTOK.
STRTOK. Okay, that's what I found and put in the chat. If anybody.
And the thread safe version is STR TOK_R for recursive. And there's also an _S, which is for safe. And what I was able to figure out, they're very close. They're both the thread safe versions of thread toke. So they also have another parameter you have to pass. You have to pass it a pointer, and that's where the buffer to the original string is stored. So it creates its own context for each call, so that it's recursive in nature. So that way, one thread's not going to damage what's going on with it. And that's what I was saying earlier, was that, if you test a module independently, it's going to work every time, because there's not a thread getting in the way or making another call to that function. So it's something, once you start working with threads, and it's something that you have to keep in mind, and something you can't test for independently. Which is why I've never been a big proponent of, the Big Bang theory, which is kind of what I had to do with belts, because I was running out of time. So I had to throw a bunch of stuff together, and hopefully it worked. Well, it didn't.
So does the documentation for those make it clear that it's thread safe, or is that a lot of time on Stack Overflow and tests and things?
Well, I mean, I have, what's considered the C Bible, right? The book that Kerrigan and Richie wrote. And anybody that wants to program in C should find one of these books. It's been out of print for a while, I think, but there's a second edition and a third edition. But it has all the libraries, and it does a really good job of keeping it simple enough to show you what you need to know, but not overcomplicating it.
Well, they keep upgrading the C standard. Do you know during your research whether or not you
could be out of date?
Whether or not you found there were any plans to make future versions of C and C++ thread safe when it comes to those functions? Or are they just going to keep separate versions of the functions around and say, don't use this one, it's dangerous?
No, I didn't, because of the additional parameter call and the stack usage. You won't be able to use the same function signature to make it thread safe, because there's not enough information there to store the context of the string that you're working with. Like I said, you have to add another pointer to it, so that basically it'll allocate stack space once you call, you do the initial call. which
Right.
happens.
So I think what you're saying is it sounds like they'll never change the original function to be thread safe.
No,
They'll never deprecate it. They'll just keep the multiple versions.
yeah.
around.
You have to know.
Well, the other thing is that, you know, you have to think about how C came about, and you know, it's there's a lot of C that's platform dependent, right? Your libraries and any other APIs that you're pulling from. So it's very much, you know, compiler intrinsic. Even when you go from like a Kyle compiler to GCC, you know, there's differences there of you know, libraries and syntaxes and what it's capable of doing. So no, I wouldn't expect them to ever change it. You know, because the actual R version actually comes from the pthread library. So it's not even an intrinsic. You have to
Yeah.
remember what's
Okay.
an intrinsic C function and what's an outside library function.
Right.
But you know, they don't do a real good job of telling you, hey, this isn't thread safe, because
Well, you know, they probably also figure that a large percentage of C programmers aren't even considering thread safety when they write programs. Only certain developers, maybe. I wouldn't even be able to hazard a guess nowadays at what percentage that would be.
well, you know, I guess it depends on, you know, what you're doing with it. I think you're right when you talk about the hobbyists. You know, professional or industrial programmers deal with that kind of thing all the time. So,
Well, I don't know. I mean, when my last company that I worked for 10 years, 5 years, never had their developers check for thread safety in the applications they were developing.
and it's one of the very difficult things to test for. You know, just because of the random nature of it. And you know, you probably remember seeing that with Belch's activity there at the contest, right? It would, you know, it might crash after 2 minutes of running. It might crash after 5 minutes. You know, you just had to find that one time where the two threads were conflicting each other, because, you know, basically the receive routine for the GPS and the AHRs, you know, they just run in their own thread. So they're just checking the serial port return, you know, periodically, you know, every, I don't know what it is, 20 milliseconds or 50 milliseconds, you know, in a loop. So anytime that those two came into conflict with one another, is the only time this happened. And then it also depended upon what it was trying to parse out. Because, like, for instance, if I was trying to parse out a null pointer into an integer, then, you know, it would crash every time. But I kept adding layers of checks. You know, is it null? Is it this? Is it, you know, the string length longer than this?
It sounds painful.
Yeah, it was. I finally was debugging it and hit a breakpoint and was stepping through where I was parsing the string out, and finally realized that between calls of string toke, because in my debugger, the other threads continue to run. So as you step, right, the other thread, if it was going to interrupt in that program step, it would go ahead and run, and then it would step to the next line. So I was able to notice that, hey, that's why it's null, or why the string length. And actually, sometimes it wasn't null. It would be pointed to, you know, some random piece of memory, or the string from the other function, which was, even though you're parsing it up based on commas, was formatted completely differently. So I was really happy. That was a 3-beer night when I figured that out.
Yeah. And my experience has been null pointers and rogue pointers are just one of the biggest evils of C and C++.
You gotta be careful.
I don't know. Your story is very inspirational to me, because if I can watch veteran programmers have trouble in the Robo Columbus, well, then maybe I have a shot at this. Because you guys, I watch you guys successfully compete.
Same here.
Years, and then all of a sudden, the guys that have competed very, very successfully are having trouble. And it doesn't make me feel as bad because I'm having trouble trying to get to the competition stage. So
Yeah.
I appreciate you filling us in on the details, because it helps us to understand that, hey, we're not the only ones that are having trouble like this.
It is kind of odd.
Misery loves company.
It is kind of odd that the Robo Columbus problems showed up at like the last minute, though.
Of course they did.
Well,
Of course they did.
Well, and Pat, don't worry about mediocrity. Just ask Ray. He comes in second all the time.
Yep.
Hey, on one more thing then, Scott, comes to mind, and that is that is this a general? I've heard things about recursion and how you really want to be careful when you do recursive algorithms. So, what's the story? Are recursive algorithms really? Are they considered an anti-pattern? Are they commonly used in judicious select applications?
Yeah, there's a time and a place for them, especially like in binary tree searches and walking trees and whatnot, where you're actually just that's the real power of recursion, right? Is that you're migrating through, let's call it a single entity, if you will. So basically, each step function is the same, but you're stepping from one to the other. I mean, think of it as a staircase with 1,000 stairs, right? So you want to step the mechanics of taking each step are the same, right? But each step is a different step, if that makes sense. So yeah, there's plenty of reason for recursion. I mean, in my years of programming, I haven't had that many opportunities, but I don't do a lot of binary searches and tree searches and that
Tree
sort of thing. I mean,
traversal.
I remember doing that in college, but that's probably about the only time I've really used that.
My summary of that would be powerful but dangerous.
Yes.
The problem is that every time you go through another recursion, that consumes another piece of stack space.
Yep.
So if you don't if you hit a bug and don't terminate your recursion, basically it'll just chew up all your available memory and explode.
Well, dynamic memory allocation is the same way, right? It's a very powerful technique, especially if you're dealing with data of different sizes, right? You don't know what the size of the data is. So, right, what do you do now? You just make a huge array that it's not going to get bigger than this. Well, when you're dealing with, especially with embedded resource constraint platforms, you can't just do that for that many times and not run out of memory. So there's a very, there's a time and a place for it for sure. But it brings up problems that you have to address and account for. You need to be very judicious about anytime you allocate something, you deallocate it.
Well, yeah. So the thing to remember is if you do find a need for recursion, and it's often for reasons of performance, you hit the classic speed memory trade-off. If you're doing it because you want a faster solution, you have to be aware that each recursion eats up more memory. So you have to be sure that every use case that you're going to encounter is going to be within the limits of what you're willing to expend in terms of your available memory. So that's what makes it very hard to use, I think, because you really have to plan for it.
You can have a recursion counter that if it goes beyond a certain limit, you're not going to come back,
Right. Well, and then you have complexity. You throw in complexity into it, and then now you reach diminishing returns.
Mm-hmm. Yeah, but if you can get into a situation where, the circumstances that would end, the next iteration is never going to come, or is, maybe not as reliable or something, then maybe that would be a good thing to do.
Another thing that I found in debugging is it's a little bit more difficult to debug a recursive function because you have to be aware of where you are on the
In the recursion.
you have to have some visibility into how far down you are
Mm.
in the recursion, and it's hard to see when you pop out, where it is you're coming out.
But the only way I've ever found to do that is just by memory, just do a memory stack watch. That seems to be the easier way to try to follow it, because you're right. You really have to know, where you're at in that process. So, I mean, I agree with you, John. It's a dangerous but powerful technique, but, and when you need it, then, that's really the more powerful way to do it. Right. And even though you're burning up memory, your processor load, can go down because, I mean, you look at, searching a tree, and the number of recursions and the number of iterations that you could go through to try to, the paths that you could potentially take in that tree. So doing it through recursion and back and, tracing the tree, like I said, it's been a long time since I've done any of that, but, that's, what it's for. So, but the thread being thread safe is a little bit different scenario than that, right? Because you've got think of it as independent programs running, sharing resources. So those resources need to be shared, appropriately, or, so that you're not bumping into each other, right? I mean, it's like trying to work your way across a crowded room and not trying to bump into anybody.
Yeah. So, Carl, I think at some point we confused thread safe and reentrant and recursive, and they're two different things. Reentrant.
I probably contributed to that confusion, but
reentrant means it's thread safe, and recursive doesn't necessarily have anything to do with thread safe or not.
True.
That's true.
But they still have, to me, the kind of abstract concept that binds them all is like maintaining separation of interest somehow. So keeping this thing separate from that thing, and whether it's this iteration of the recursive algorithm or whether it's that thread versus this thread, somehow you need to keep them partitioned. I don't know.
Right.
Well,
And
I think what you're driving at too is that some of those threads are sharing resources.
Yeah.
Whether
at the end of the day,
whether it's, pulling from a queue that someone else is loading, and so you're right, where you have independent threads running or independent processes running, but some of those have to communicate and have to share memory or share resources, and that's the same thing with what I ran into with the C library. Even though I didn't write that code, those two threads were trying to basically share the same resource, and that resource wasn't safe in that context because it was only meant for a single threaded application. Right. So when you have multiple threads, you have, randomness basically, where you can't predict, okay, I'm going to execute code in this sequence. You can't predict that because you can only predict the sequence within each thread, but you don't know, as I'm executing this thread, now I'm going to stop executing that thread, and I'm going to come over here and I'm going to execute this thread, and then I'm going to come back to this thread and I'm going to continue executing. Right. So if you're sharing resources and this other thread did something to that resource while you had given, because, you only, in what we deal with, even with pies, you got multiple cores, but you're still really only running one instruction at a time. So if this resource did something or this program did something to the resources this other program's using, and think of threads very much like independent programs,
Yeah.
right? I mean, that's what I ran into, and it was a struggle. It was,
So
it was
how
a
many
learning
hours do you think you spent on that one problem before you found out it was a thread safety issue?
Oh, hundreds. I mean, I want to say hundreds of hours, but
Hundreds of
probably
hours?
only about 10 minutes.
Oh, it felt like hundreds. Okay.
It felt like
Wyatt, let's hope that complexity doesn't bite you in the ass next year.
yeah, I'd hate to come in second.
You too.
Yeah, for all that work you put in there.
All
you
that
know.
smack talk. Oh my goodness.
Oh yeah.
Oh, and if you're interested in making recursive calls that you don't have to worry about the stack, there's something called tail recursive, so that the recursive part is at the very end of the function, so it can pop the stack before it makes the next recursive call.
So it basically has its own stack space then?
No, well, what it's doing is the recursive call is the last statement in the function, so that lets the compiler pop the stack before it, so it doesn't pile up the stack.
But if you're recursive, then when you return, when you come back around to that, you still need that stack context, don't you?
Well, no, the returns, I don't know how to explain it. The returns built into the stack so that, or I mean, the returns built in, so it already has of the context when it's returning. If that makes sense. So it's like if you're just adding a number to the, the previous number, it doesn't need the context anymore. Basically, the compiler's able to unroll that stack.
Cool. All right. Well, that's a pretty cool discussion, very technical. So next in queue, so far we had, I'll go next with a brief update, and then we had John G, John K. Would anyone else like to jump in the queue after that? At this point?
Well, I got a semi update, but
Okay, we'll put you
it's
in
a
that.
pre-update.
All right.
I have a question I want to ask, so I'll ask that
Okay.
when my time.
All right. Very good. All right. So my update relates also, it pulls together in a way or it leans on the kind of Big Bang random problem thing that Scott was talking about. And then also, Pat, your suggestion from last week. So I also worked on a Robo Columbus duct tape and baling wire robot. And I found I was trying to understand why it was making it very close to the cone, but not close enough to even earn a single point. And then it just decided that it found the cone and turned around and went back. And that was I was mad at it. So it turns out that in last week I was asking all about the UART transfer issues, because for a guy that's actually programmed FPGAs that went in thousands of military vehicles in the field, I had never really spent much time with microcontrollers actually reading UARTs. So anyhow, I found out that I was having last week I showed videos that showed the errors clearly. I had a camera that was sending data over a UART down to a Mega, which was consuming it and using it to steer and stop the forward motion. And I noticed that that it was leaving the sending side just fine, but it was getting corrupted or not getting correctly to the receiving side. So it's clear now that after all our discussion, I hope last week, that it was buffer handling related. I managed to pretty much stop all of the errors. It's nice and robust now, and I did the two things. So Pat, your suggestion to try speeding up was really helpful. I changed it from 9600 to 115.2. And then also I noticed that it was my inner loop was sampling the UART less often than I thought. So it was only sampling about 10 hertz. So I bumped that up to 45 hertz. And as soon as I did those two things, boom, it stopped kicking out any errors. So it was able to keep up with, the receiver was able to keep up with the source. But unfortunately, well, or fortunately, let's take an onion layer at a time. Now that I fixed the transfer errors, I also cleaned up and made more robust the way the data was used to steer. So at the time of the contest, the algorithm would take whatever data was coming in, and it had a really weak test as to was this valid or not, and then it just took it and it used it. And I think probably some fraction of the time it was like a monkey throwing darts at the dartboard. It just picked. But now that it's getting only valid looking data, and it's applied much faster, now the heading loop doesn't work so well. So it doesn't respond fast enough. So I got to change loop gains. And now I got to work on I also got to work on the cone detector because this now that I got the transfer errors hidden or gone, disappeared, now I can see how badly the cone detecting pipeline works in the vision side. So now I got to fix the vision pipeline, and I got to tighten up the heading loop. So Robo Columbus 2023, here we come. Just don't happen too early because I'm, like an hour a week at this or whatever. So I'm right there with you, Scott. I won't be chasing after first place like Ray, but anyhow, maybe second place. I would have beat you this time if that damn thing wouldn't have screwed up just at the very end. I would have beat you, Scott, but anyhow, not this time.
Sometimes I'd rather be lucky than good.
Well, it reminds me of the old saying we used to have that the first 90% of the job takes 90% of the time, and the last 10% of the job takes the other 90% of the time.
Exactly. Exactly. So anyhow, who'd ever thought that just reaching the first cone robustly would be a 3-year project? But well, here we are. Okay, well, that's my update. I don't know if it's disappointing or humorous, but anyhow, next in queue, we had John G. What you got?
Okay, so the continuation of what I've been doing is, this idea I had with my security camera I have on the street. The problem I'm trying to solve is that I have a problem with distance, is that I can only communicate with Wi-Fi over maybe 100 feet. I'd like to be able to take, a camera and put it off at some remote location and be able to get pictures back. And so I've got these two NRF 24L01 radio transceivers that I'm playing with. And so I'm trying to create a sort of a file transfer protocol between the two where I could be up to 1 kilometer away from the camera and get pictures back. So let's see, let me put my screen up here. So I have here we go. Let me move that over. So I've got a sort of a protocol I developed here for my file transfer. The problem here is that the transceivers that I'm using, they can only transmit or receive. They're only half duplex. So I start out with the server side, the camera side, just listening for this get files request. And then he basically says, okay, I've got a file for you. Here's the name. The client says, okay, I'll accept that. And then he says, okay, I've got this many bytes to transfer with this file header. And then he starts sending this file data in packets. And I can only send 30 bytes at a time because the size of the FIFO of each FIFO entry for this transceiver is only 32 bytes. So I send a number of packets, and then occasionally, after sending 255 packets, I have a client come back and say, well, tell me tell me if there were any packets that I missed, because he includes a packet number. So it's conceivable I can lose a message. It's a radio link, right? So the client continuously keeps up with the packets he's received, and if any are missing, you re-request them. So we've got this whole protocol to do this. So I've got the two transceivers set up here. On the right, this is the server that has all the files. I've got a few test files out here, which really the smallest ones are only a few bytes in size, going up to maybe 10K for a text file. And then I've got some image files that are close to around 200K in size. So if I run this, right, start the client up. But that was a server. Start the client up on over here on the left side, right? And tell it to give me all those files. But right away, it gets the small files really fast.
So what's the resolution of your video image if your 200K is really small, isn't it?
It's fairly small image.
Is it like quarter VGA or something? Or
I don't remember the exact number here. And this might take a while. So you can see it's basically working. You can see the missing packet request on the left side going out. And each time I've discovered so far being in very close proximity in the same room, I'm not having any trouble at all losing any of the messages. And I've got checksums on the data, and I'm not actually getting any checksum errors either. But this is like the ideal environment at this point. Once I start separating the transceivers some distance, even in setting the transceivers for increased power, there is a possibility that I'll get packets corrupted or may even drop packets entirely. So far, okay, there we go. There's the problem right there. That's what I'm waiting for. So in the middle of sending the image file, I may have to stop the server side. Okay, that's good. I'll leave it right there. So he was doing quite well. And then at some point, he stopped. The client side says, "Oh, I'm not getting packets anymore." And on the server side, he said, "Hey, I'm not getting that last missing packets request from the client." So I got to figure out, well, who's at fault? So far, what I think I've been able to determine is the problem is when you have to switch between transmit and receive, because you've sent something from the server that now the server's got to respond and go back. I mean, the client's got to respond and go back to the server. The server's got to be switching from transmit to receive. And if he doesn't do that in time, then the message is lost. But switching back and forth like that with gaps, throwing delays in there, all right, to make sure that you have to always make sure that one side is listening by the time the other side starts transmitting. But that eats into the total transfer time. So with these image files that are about 200K at the current rate, it takes me like 2 minutes just to send one image, if it were even successful. And I've gone so far as to get that first file has been successful before. It's not exactly a repeatable error, but I imagine it might have something to do with maybe on one side or the other, something is interrupting my program briefly enough to where the switch between transmit and receive is not happening fast enough. So I was going to experiment with slowing things down. But it's so far kind of a little disappointing because the transfer rate is not exactly something to brag about. I'm actually considering at this point maybe going to, and I'm going to stop sharing here. I'm actually considering at this point maybe getting a couple of more transceivers so that I have two independent channels. One's always transmitting and one's always receiving, so I never have to switch. And I never run into this vulnerability where when switching, somebody drops a message because they didn't wait quite long enough. So that's kind of where I am.
Have you thought about flushing your buffers? I mean, I don't know what kind of transceivers you're using, but typically when I do a half duplex setup like that, before I try to read when I transfer the bus, before I try to read any data, I normally would flush, or basically before data gets sent to the receiver, because in that switching, especially with UART stuff, I've seen, garbage or, a false start bit kind of trigger saying, well, this should be a byte. And basically the UART layer just gives you a 0 because it was a false start bit or an FF, depending on, what the noise was. So have you
Oh,
thought about something like that, John?
so far, I don't think I've seen any evidence that there's like noise, or unexpected responses anywhere that's causing this. I think it's just timing at this point. And I want to be careful with flush because you don't want to flush useful data, right? You don't want to flush a message that you expected.
Well, but while you're waiting, right, you have a delay, right? So maybe while you're delaying, to send the message or to receive the message, seems like you would have a window there to at least something to try.
Yeah, well, as it is right now, I've got the delays down to close to like 1 millisecond, and even that's eating into my transfer time. So I think maybe I'm going to go with getting some more transceivers, and for one thing, when you do miss something, the recovery logic in my protocol gets very complex. Having independent channels will really simplify this thing greatly. To have independent channels, I think the only problem I'll have to deal with is going so fast that I overrun the buffer. Because these transceivers, these NRF 24L01 transceivers, their FIFOs are only 3D. Ray, you're muted. Ray, you're muted.
Oh, sorry about that. I said it could be another example of what I would call Scott syndrome. It's so complex that you may never figure it out,
Hey, I figured it out.
Eventually, yeah.
And that was you said NRF 24L01?
Yeah, that's a very, very common transceiver used for, I'm sure some of you recognize it, used for remote control, planes and cars.
Okay, I just put a link out there. It also looks quite cheap. There's 10 of them on Amazon for $15.
Oh yeah, they're so mass produced, they're really inexpensive.
Yeah. Huh. All right.
Yeah, I would assume that like if you're trying to send video images and it does lose synchronization, I would think, to try to recover lost frames may not be the thing to do. I think, you may just throw out like the remainder of a frame or something and try to resynchronize at the beginning of the next frame or something. Because
well, actually, what I have on
that's complicated.
Well, actually, what I have on the client side is on the assumption that it is possible to lose packets. What I'll do is I'll have a buffer of in code. I'll have a buffer of up to 255 packets, and at the end of packet number 255 or whatever the last packet is, if I haven't received the whole list, I keep that buffer available. I don't write it out to disk yet. And I go back and send that missing packets request back and say, well, I've missed number 5 and number 20 and number 36. And then I have the client resend those and I'll fill them into their positions in the buffer. And then once I go through that process enough times where I don't have any missing packets left, then I'll write that buffer to the file and continue with the next group of packets.
Pretty
It
spiffy.
sounds like you'd have to have a pretty large buffer on the transmitting side, though, to keep all those packets for a while, right?
Well, no, there's really on the transmitting side. I don't remember how to do it. Yeah, I'll think about it. I don't think that there's. I think I have a buffer on both sides, but now come to think of it, I can't remember.
Oh, that's okay.
I mean, it's at both. It's a 255 packet buffer, which is about 7K bytes. So it's not huge.
So do you try to do that resynchronization like at the end of the frame? Is there some dead time at the end of the frame where you're just not transmitting anything, or?
Well, no, I'm not doing live video. I'm just doing images. It's just a file.
Oh, okay. So it's not like MP4 files that are.
No, it's just a file. I'm just doing file transfer. I mean,
Okay.
doing live video would be really complicated.
Yes, it would.
I don't really want to do that.
And you don't care about latency so much.
No, just
What
gotta make sure I get the file across.
what's what's the information in the file you're getting back? What is it?
Well, generically it could be anything, but at this point I'm planning for it to be images, like images from my security camera that would be about 200K JPEG file.
Right now you're just trying to communicate, is what you're saying?
Yeah, right. Well, right now I'm just trying to make sure that I can send a relatively large file without losing any data and being able to complete the file.
All right.
Well, I'm done.
Okay, cool. All right. Next, we had in this order John K, Michael K, and Doug D. Anyone to add to the queue after that? Okay, John K, what do you got?
Okay. Well, unfortunately, Harold's not here, but you may want to send him this link. It claims to be ultimate guide for the self-balancing. So, and it basically talks about, the wiring, using that, and the sketch. Okay. So that's number one. And then there are a couple others, but I won't overly go with the others other than this one. I'll run this one briefly. So they use a styrofoam, and then they get to that stage. Okay, are we running?
It's muted.
Well, yeah, I just was running, see if it did that. Because there's that one. So looks like he has it balanced outside. Unfortunately, the one that I was hoping to track down, I had found the other read that was even better about discussion of the balancing of and billing. And basically what it was saying was that it's important, like on this one, is everything's already sort of semi-balanced and aligned. So it was saying, if you have this right here, balance it with something else type thing. But this one looks like he balanced pretty good. So you may want to look at that. And then there's one other one, but I'll have to switch the window for that one.
It's like they're cheating. They're using an umbilical.
Well, yeah, that one I almost wonder about a little too, but
changes a lot of things if you had the mass of a battery somewhere in that structure. Yeah.
I saw a battery. I saw a battery at the bottom. I don't know what the umbilical was for.
Oh.
And then there's this one. So this one he may want to look at too, because this one actually started off with that, leg thing balance. It sounds like this is the same group that did that one. So he may want to look at this more closely because they have a series, seemingly. And in this case, it talks about the reels, building the control system, and then some. And it looks like it's pretty nicely done because,
Do they explain the 133, magic
yeah.
number?
Oh, yeah. Well, that's not really a magic number. It was magic for that guy based on what I've read up since then.
Yep.
So this talks about G and the movements and that. So this would be another one I would say Harold needs to look at more closely. Unfortunately, I didn't know if Harold got his running further than what he's at on it.
Hey, John, can you put those links in the chat?
Will do. So that's basically what I have for info. It's mainly about, self-balancing robots.
Oh, but what caught my eye is that article in the lower right, how to balance robot PID tutorial in under 2 minutes.
You want to see that one? I was not impressed with that one. But,
Well, they made it sound really easy.
let me
2
see
minutes, yeah.
if I can do this without. Yeah. That. It may take a little longer.
That's going to be a step 1, get a robot. Step 2, step 3, balance.
Yeah, not as impressive in my mind, but there it is. Okay.
Why are you not impressed? Just short on details?
Yes. I mean,
Oh,
basically, it's they'll have numbers there. And other than the fact he's using a regular toy car, that's the only thing I was impressed by it.
So he's just basically showing trial and error is what he's doing.
Right. Now he
Starting
added,
with case of P.
supposedly it's you set for a better description, but we'll see. But yeah, all you see there is, trial by error. So to me, it was, Now, whether or not he improved it on that one, I don't know. So let's flip there. Yeah, maybe he does describe this a little better there. Okay, yeah, this one he actually described a little better, it looks like. So of the two, I would say this is better. Because it talks about the PID values and that. But even on this one, notice how he has this more very centralized. It's not, on one side or the other. It's all line up. And see, that's an important part of it. So.
And he's doing it with plastic motors and wobbly wheels.
Oh, yeah. Well, that's what I said. This is a relatively cheap one. It looks like it does good.
I did like that last scene. Did you go back and see how he's got like a D-shaped thing so that when it falls, it doesn't damage anything? That's a little different.
No face.
Good idea.
Oh, yeah. It protects the stuff inside with that, that right there. Oh, yeah. It's a nice design. But yeah, I'll put these in there. Now, this guy, yeah, you also have it supposedly bounce off the curb. So yeah, if you want to look at that, and especially maybe Nesri, if Harold's on, we can point this out to him more.
You might want to just tell him to go look at the ARC Robotics channel.
Yeah.
If you go ahead and put that in the channel.
Okay.
That's probably, it looks like he's got a lot of videos on it.
Oh, yeah. Well, it's a series in the case of that one. And yeah, and they look like they did a very detail on that regard.
I'm missing the context here. Is Harold planning on building a balancing robot?
Yeah,
or just
He
following
he's-
the existing
He's in the
plot?
process of doing it.
Oh, okay.
He's been chasing it for a couple of weeks now, couple of months, I should say.
And the key problem right now seemingly is the balance and part, the PID loop and that. Seemingly that's one of the key parts to it. Having the proper feedback and the calculations.
I have to admit, I'm a little surprised that these guys can get all of this performance out of those little crappy yellow motors.
Well, that's the part I find interesting. So I may see it breakdown and Bill Hatchet one based on, especially this one. It looks cute and it looks straight design wise. I do like that.
Maybe they're overdriving the heck out of it, and you end up with melted motors at the end of a run or something.
Mm,
Feedback loops are great, aren't they? Just
Yep.
feed them whatever slop you got and let them take it out. Let the
Yeah.
loop fix it.
You know, I don't see where the encoders are on that thing.
they don't need them.
Oh, they're
They're
using
using that, the
Yeah.
balance.
IMU.
IMU. Okay.
Accelerometer, gyroscope, whatever.
Right.
Mm.
The power of math.
Yeah.
Which is why this toy robot, well, this toy RC car, basically, it doesn't have any colors, and it's basically the same thing as this. The only difference is it had the 4 wheels, and they were big enough that he could literally put it on an end.
So all they're using is PWM to control those motors.
Yeah, and let's see.
Well, they'll use PWM to drive the motors at one speed or another, right? But then
Right.
they'll use the feedback from the IMU to determine whether they should make the motor go faster or slower.
Right. Gotcha. Yep.
And then they'll rely on the math of the feedback loop to just take out the sloppy response of everything. Well, cool.
So I will post those. I assume, they'll be in the video slides for Harold.
Yeah, put them in the chat, and we'll get them out there.
Okay. Okay, that's it for me.
Cool deal. All right. Well, next we had Michael K. and then Doug D. Would anyone else like to get in line after Doug? Not yet.
I'll show you.
Doug D.
I
Or
think
Doug.
you-
Sorry, I meant to say Doug P, not Doug D. Sorry.
Right, because I have nothing.
The P and the D are very similar. Just one has a tail. Like, okay.
He's smarter than I am.
No, you guys. Okay. Michael, what you got?
Me?
Yeah.
Oh, I thought you said Michael K.
Okay. I need to go back to alphabet school. Michael, go for it. It's all yours.
All right. So
All right.
y'all remember this a few months ago? I was messing with this arm,
Yeah.
robot arm. I'm gonna make a new claw machine with that robot arm. So I'm gonna have it on a turntable, and I'm printing these big old gears, man.
Wow.
It's huge, huh? But I decided to go with a bigger turntable. So I'm even having to print a bigger gear. So anyway, I should have these on the gear and have the smaller gear running with this stepper motor. Maybe I've got several of these NEMA 17s. So control this arm, have it turn 180 degrees. But that's why I said I'm kind of semi showing you something this week, because hopefully maybe next week, the week after that, I can do a little demo of it going around, swinging around. And but that gear is going to be pretty big. So it's 120 millimeters. So
Does your Lazy Susan bearing,
this is a
touch or
Susan, yeah.
Yeah.
Right. You buy them on.
Does it snag if you, kind of
Well,
lift up on it or push up on it?
that's why I went to a bigger one because I had a smaller one that gave me that problem. You know,
Oh, it did.
I'm
Yeah.
hoping this big one, this larger diameter, won't have that slag. Also,
Yeah.
I have, as an emergency fallback, I have these rollers, these casters I bought. The little casters.
The ball wheels. Yeah, nice.
Yeah,
Oh,
just
yeah.
in case that sag you're talking about, Ray, gets pretty bad.
Yeah.
So I've got that. I got a lot going on in my brain about all this. So I anticipated that sag, but it looks like these guys are doing pretty good, man. So
Hmm.
and they're big. That's over 6 inches.
What is your motor driver module that you're planning to use for that NEMA 17 stepper motor?
I was just probably going to use one of them. What do they call them? Standard. What do we use those guys to run all the 980?
L298 in.
Yeah, the ones you buy that
Oh,
we
right.
use.
Yeah.
Huh?
And the Palo drivers.
Where's one at? I got one laying around here somewhere.
Oh, I think he's talking about an L298.
You know, 10.8, yeah. One of those standard motors we use on these robots all the time. I don't know the number of it. What is it just again?
An L298.
Yes, an L298 will run these motors right here.
Well, L298 that's just the chip. I'm talking
Well,
about.
no,
Right.
it's the.
I mean, I'm talking about.
Are you asking the driver?
Yeah, because I've got some NEMA 17 stepper motors I have not put to use yet for anything, but in the future I, kind of would like to know what kind of driver.
Well, that's that driver we use on these robots. I wish I had one laying around here.
John, there's all kinds of
Oh,
drivers
yeah,
for
yeah,
stepper motors that are
yeah.
used in 3D printers.
Yes.
But this driver, the drivers we use run just fine. I ran my claw machine that I've had for years runs with those drivers.
Yeah. But you can get if you need micro stepping and that sort of stuff.
You need
they're dirt cheap. You know what I mean? You can even they use them in Gerbil boards. They use them in 3D printers, Pololu package
CNC machines.
CNC machines.
Let me present this. What are you talking about? What I was talking about?
No, they're
Got the it starts out A something. There's 3 numbers after it.
There's several of them. Different companies make them.
Let me. This is what I'm using. Y'all see that at all? Is it presented?
Yep.
Oh, okay.
Yeah, those L298 ends.
Yeah. Like any of the drivers that would plug into a ramps board.
Yeah.
Well.
Yeah. Oops.
Well, I said, L298 is just the chip, which you could use for any power stepper motor. What I was really interested in was which modules will deliver sufficient power to drive a NEMA 17 stepper motor.
I don't need anything that fancy. I'm just going to use limit switches to stop this turntable. It'll just hit and the motor will stop. And I don't need anything real fancy. But we'll see what happens. If it doesn't carry these things will do how many? Like 3 amps, won't they?
Depends on the voltage, but at least maybe 2 amps.
These things.
Pololu has, I couldn't tell you how many different drivers, stepper motor drivers Pololu has now, and they were the P in the RAMPS. It was a Pololu driver that was used on that. They have all kinds of, different voltage ranges, different current ranges. And like Gerbil boards or, ramps 1.4 boards. I don't know what the ramps are up to now, but that's the version that I have. And
so if you were looking say on Pololu. Of course, you can
Mhm.
find tons of motor drivers, all right? But if you
Yeah.
wanted to find one that will drive an NEMA 17 stepper motor, you'd probably look for the words NEMA 7, compatible NEMA 17 or
Well,
capable of
it
driving
depends.
NEMA 17.
It depends on what you know about your motor.
Yeah.
If you actually know something about your motor, you can do it from the current. The stepper motors are a little different. Otherwise, you want to drive them at their current and you just let the voltage go where it goes. Okay. And so usually the 17s are generally somewhere between 1 to 1.5 amps.
Okay.
But if you don't know what amperage it is, these things have a pot where you can these modules where you can adjust the current that's being supplied to the stepper motor. And like I say, it'd start off with an amp. And if that's not enough powerful, you might be able to boost it a little bit. But if the motor's starting to feel really hot, because they're going to be getting that current even when it's sitting there, you can tell, well, maybe I'm giving it too much current, because you don't really want your stepper motors to get real super hot. So anyway, they can be warm, but you don't want them to be hot. Here's the link to their page, a whole page of them. Now, that's all said. So and Pololu is one of our sponsors, and I like them and I buy from them whenever I can.
Yep.
But these things are so cheap. These things are so cheap on eBay. I mean, we're talking probably, I haven't looked at them since the big inflation, but you used to be able to get them for $1 a piece. So it's something to consider. And they have different features. The ones you want to look for is max current and max voltage and
Number of steps.
They'll micro
Microstep.
step. And you probably don't, sometimes those micro steps really get crazy, because it really depends on your load. For example, like on a 3D printer, there's essentially no load. Okay, so you can do a lot of micro stepping, but if you really loading it down, you probably don't want to go to 96 micro steps.
Yeah, well, it looks like all the ones that are listed there, maximum continuous current is between 1.1 and 1.5 amps. So they're all, like you said, you can use any of those just for your particular application in terms of voltage.
Yeah.
What do you plan on doing with yours?
The nice thing about if you get them from Pololu, is that when you want to tune the current, everybody knows exactly it, because it all comes down to the size of the sense resistor that's used on the module. And when you go to Chinese ones, there's 2 or 3 values that they use. So the voltage you're looking for to set the current is different. All right. So if you can read, there's plenty on the web on how to set the current.
And somebody asked what I have planned. I don't have anything planned. I'm looking forward at some point start playing with those.
Mm-hmm.
What are you going to do with your steppers? What do you plan on doing with them?
I just said I have no plan.
Oh.
I'm just going to play with them, and at some point I'll have an application.
Yeah.
Well, what I was saying earlier is it doesn't need a whole lot. It just doesn't need a whole lot to turn that little turntable. As far as being very precision and all that. So I'm just going to use one of them L298Ns.
If you got one, do it.
I got tons of them. You get them you used to buy 5 of them for $10.
Mm-hmm.
And but I'll probably, if it won't handle the current, I'll go from there. But
well, they can supply.
I have.
I want to say, can they? I think theoretically they can do 2 amps per.
They can do 2 amps. I just looked it up.
Yeah, that's you might not want to run it there, but that's going to be should be plenty, way plenty.
Also that PWM pin on those controllers, on those drivers, You can shut the current off of those steppers. Just turn it off. It'll disable it, and it won't be running that stepper all the time. So you can actually turn them steppers off.
That's fine. As long you don't want to do that on a CNC machine or a 3D
No,
printer.
they're playing a CNC. I'm doing. This won't be a CNC, so it's not that critical.
Yeah.
Now I had to. Let me tell you something about my claw machine, and I think I shared this a few weeks ago. Is that I kept building. I kept current on my bench power supply. The current kept building and building and building because I had 5 steppers on there. Well, they were all turned on in a stall state, and I couldn't figure out what was going on because I finally figured out I could shut them off, and the current would go to 0. And but they were in like a neutral state at that point. But since I'm not running a CNC, it's not that big of a deal, you know. And so it was real. It was kind of pretty cool to find out I could turn the current off on those steppers. And
on your arm, you might not be able to if you got a stepper on your arm because it might just sag.
These arms are going to be. These are
servos.
The stepper's just going to be swiveling it like this. The servos are going to be in the arm. So.
Well, if the drivers work similar to the DC motor drivers I'm familiar with, when you say turn the current off, there's 2 ways you can stop. There's 2 ways you can stop the motor. You can stop it with basically a short to the coil, where essentially you have a magnetic brake, so that when you try to turn the mechanism, you get resistance because the back EMF is giving you some resistance. Or you can tell the thing to do open circuit, which basically means that it's freewheeling. You could spin it and get no resistance at all. One is the first one is essentially a brake operation, and the other one is just, I don't know what they call it, just open.
Yeah, on steppers, because they're they have steps. If you really don't have a whole, let's say he's just trying to rotate that large gear. There's enough resistance from just spinning. You can't take a stepper motor and spin it, because each step is going to go tunk, 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 tunk. So, if he's got it mounted like this, and he can cut the power off and it won't move, but that's a very special application. So, yeah, because you're right, John. I'm just saying, is in his situation, I see where he's going, because he's not. There's not going to be anything swinging the arm. No kid's going to reach in and grab it and go chunk like that. So
They might,
I know. I said that because if a kid can do it,
it'll be done. They'll do it.
Yeah. But anyway.
They won't. We'll get a hold of it, and we will.
Yeah.
You just got to keep them out of the enclosure, I guess.
There's Lexan protecting the thing. So, yeah.
Okay, is it my turn yet?
It is, Doug. You're up.
Okay, mine was just a question to Ray. Hey, Ray.
Oh, yes.
What on your wristwatch? Your wrist.
Yeah.
Your wrist.
A chick magnet.
Yeah.
Yeah.
What battery are you using on that?
I was using it's actually a battery pack that can, I'm not certain how many 18650s it's got in it, but it produces 5 volts, and
Okay.
it has a USB connector on it, and I just plug it into that board.
Okay, so you're actually using it up at 5 volts.
Yeah.
Okay.
Yeah. It's used.
How many milliamps does it have? Is it like a battery, like thing to charge your phone up with?
Yeah. Yeah.
Okay, so it's at least 2,000.
Probably. Yeah. I know. I guess the last ST meeting that some of us went to, Arrow had these little, I think, blue battery charger packs. That one was a lot smaller, and it works probably for at least an hour, and then I have to recharge it, so it's a lot smaller. But the bigger white one, I don't remember, maybe 2400 milliamp hours.
Okay. All right.
Or-
I've just been thinking about making something like that with the Wixels. And
Oh, okay, yeah.
so,
Maybe he calls it his Dick Tracy robot controller.
yeah. Yeah. So I just, what, get to do the 3D printing. Mine's going to be slicker than yours, though. Right.
It probably could be. I just got one off of Thingiverse.
I'm not going to
It
have
didn't
any.
even fit that well.
I'm not going to have any duct tape on my hand.
Oh, well, let's see. Did I have? No, I didn't have duct tape. I had elastic and Velcro and.
Well, I'm just kidding with you.
Doug, are you
Okay.
going for the supermodel magnet?
Yeah.
Nerd magnet.
Yeah.
Nerd magnet. Okay.
Yeah.
Well, whenever you pair that with a pocket protector, I'll know we have really
We
hit
really
some kind of
determined.
new low.
Yeah.
Okay.
Yeah, that particular one, you had to supply 5 volts with it, but the ESP32 modules, they actually, and some of them have it, some of them don't, but you could plug in just a 1S lithium cell, and it would, it drops it down to 3.3 volts, and you can do charging if you've got a USB connector supplying 5 volts to it.
Mm-hmm.
So it does charging. They're really nice, but that particular module, I do not think it had a battery connector on it. There's the plus version, I think, does. There's a, what was it, WT32-SC01 plus, and it looks a lot different. It doesn't have the 2 40-pin connectors on it. It has an SD card slot. The screen is still the same resolution. It's still touch screen, but it's got a lot of different stuff in it. And now I don't remember if that one's got the battery on it, or the battery connector, but I think it does.
All right. So how big is your range on that? That's probably pretty good, isn't it?
Random Nerd Tutorials checked it out. I think I'd have to look at the article again. It's been too long. I'd be guessing at this point. I'd say what comes to mind is 400 meters. I don't know if that's right or not.
Okay, so it's really long range compared to a Wixel. Wixel only 50 feet. So
Oh yeah.
yeah, I was just looking for some short link. So
Yep.
Okay, cool.
John, I don't know if you've ever heard of Random Nerd Tutorials or not, but he's got a website with all kinds of stuff. And one of the things he does for the ESP32 cams, that's, it's a small module with a camera on it, and you can transmit video images over Wi-Fi. I wonder if there's anything in there that you could use to, if that's what you eventually want to do, is, transmit video images.
Well, the problem statement is that Wi-Fi is too short a distance. The reason I'm going with
It's still too short.
Yeah.
Okay.
is the reason I'm going with these NRF 24L01 modules is that you could get up to, according to the spec, up to 1 kilometer away.
Wow. Yeah, I don't think you can do that with those old ESP32 cams. I don't think they'll go that far. And they do use the Wi-Fi standard, so, to transmit images. But anyway, I thought there might be something in there. I know he does have some things that check for, like packets with errors in them and stuff like that. And I think initially there were issues with I'm not certain if it's called pairing or not, but occasionally it's like you'd lose synchronization on transmit end to receive end, and he had worked out some of the bugs of that. So I I don't know.
Yeah.
It's
Well,
free.
I have looked.
Might want to take a look at it.
Yeah, I have looked online. Right now, I'm doing this all in Python because I prefer to use Python. And there's an NRF 24 Python library available
Uh-huh.
that I'm using.